Parametric equations. Alright? Our first problem, we're going to convert each set of parametric equations to a single rectangular equation. So if x is equal to 2t, t will be equal to x over 2. Once we have isolated t, so first step we need to isolate t. Once we isolate t, we plug t into our y equation. So we're going to plug t into our y equals t squared plus 4. Alright, so in that case, we're going to have y is equal to x over 2 squared plus 4. Alright, so y is equal to x over 2 squared plus 4, which means y is equal to x squared over 4 plus 4. Alright, and that's all we have for this problem. Another representation could be y is equal to 1/4 x squared plus 4, but both are sufficient. For 27, x is equal to 3t plus 9, which means to isolate t, x minus 9 over 3 is equal to t. So plug t in, and we plug t in, we're going to have y is equal to x minus 9 over 3 squared minus 7. And so that's going to give us y is equal to x squared minus 18x plus 81 all over 3 minus 7. And I'm willing to leave it like this. Alright, so that's... So I'm sorry, I should never use the word it in mathematics. I'm willing to leave the equation like that. Especially if the answer choices are multiple choice, then you should be able to find out multiple choice value that is equivalent to this. X is equal to 1 over the square root of t minus 3. Y is equal to t. So first we have to multiply, to isolate t, we're going to have to multiply each side by the square root of t minus 3. So x times square root of t minus 3 is equal to 1. The square root of t minus 3 is equal to 1 over x. T minus 3 square root of t minus, so actually I'm gonna undo here. So t mi gonna have to go back to where I was. Alright, t, if we can square both sides, t minus 3 will be equal to 1 over x squared. 1 squared is 1, x squared is x, so it's going to be equal to 1 over x squared. Add 3 to each side, and t is equal to 1 over x squared plus 3. So if y is equal to t, then y is equal to 1 over x squared plus 3. X is equal to 3 cosine of t minus 1. Y is equal to negative 2 sine of t plus 4. So our goal is first to isolate our trig functions. We're going to isolate our trig functions. And when we isolate our trig functions, the cosine of t is going to be x plus 1 over 3 is equal to the cosine of t. Y minus 4 over negative 2 is going to equal to the sine of t. Now, after I isolate the trig functions, apply the Pythagorean identity. Apply the trig Pythagorean identity. And that trig Pythagorean identity is going to be x plus 1 over is going to be the sine squared of t plus the cosine squared of t is equal to 1. All right, and then from this, sine squared of t plus the cosine squared of t is equal to 1. You are going to have to find if y minus 4 over negative 2 is the sine of t, y minus 4 over negative 2 squared is the sine squared of t. If x plus 1 over 3 is the cosine of t, x plus 1 over 3 squared is the cosine squared of t. This is all equal to 1. Now, y minus 4 over negative 2, this is going to become y minus 4 squared over negative 2 times negative 2 is 4, plus x plus 1 squared over 9 is equal to 1. And so this is our final answer. So this is actually the parametric form of an horizontal ellipse center at center at negative 1, positive 4. Continue. A equals 2. B equals 3. All right, so that is 29. Okay, so let's go to 30 now. Use each parameter to write the parametric equations that can represent each equation. X is equal to 3t, and y is equal to x squared minus 9. So x is equal to 3t, y is equal to x squared minus 9. So if x is equal to t, so use each parameter to write the parametric equations that can so we're going to have to isolate t. So t is equal to x over 3, and y that's why I wrote this problem wrong when I was solving. So that's why. So like if x so here's the deal. If x is equal to 3t, then we can plug the 3t in for x. So y is equal to 3t squared minus 9, which means y is equal to 9t squared minus 9, and x is equal to 3t, and that's the entire equation. All right. Here, x is equal to t minus 2, and yt is equal to 2 minus 12. So in this case, you already have two parametric equations. So two parametric equations are already represented. So therefore, two parametric equations are already represented, and so therefore you can't really do any work here. Can't really do work here. All right. Let's keep on going. All right, this is a fun one. Plane A flies with the path given by the parametric equations x is equal to 2t minus 4 and y is equal to 8t. Plane B flies with the path given by the parametric equations x equals 4 minus 3t and y equals t plus 4 over 6. If t is the time in seconds, by how many seconds do the planes miss colliding? Okay. So here's what we have to do. First, we need to find some information about plane A, and we're going to find some information about plane B. If x is equal to 2t minus 4, that means x plus 4 over t, or x plus 4 over 2, is equal to t. Now we can plug this into when y is equal to 8t. We can plug x plus 4 over 2 is equal to t into y is equal to x plus 4 over 2. Okay, so y is equal to x plus 4 over 2. times 8. And so that means that y is equal to x plus 4 over 2 times 8. So that's for plane A. For plane B, x is equal to 4 minus 3t. So x minus 4 divided by negative 3 is going to be equal to t. And when x minus 4 over negative 3 is going to be equal to t, y, which is equal to t plus 4 over 6, means that y is going to be equal to x minus 4 over negative 3 plus 4 over 6. So now we need to find when these two intersect. So we're going to use a calculator to find intersect. So we're going to use our calc to find intersection. So I'm going to call this y sub a, y sub b. I'm going to use the calculator to find the intersection of y sub a and y sub b. So let's break out our trusty calculator. Our first equation is going to be let's do 2 parentheses. So we can do 8 first. 8 times x plus 4 divided by 2 x plus 4 divided by 2 yes, because we have x plus 4 over 2 all times 8. And then yb is going to be a little more tricky to put in. We're going to have to do a parentheses and then a second parentheses and then a third parentheses. So we're going to have x minus 4 divided by negative 3, close that parentheses, so 1, 2, plus 4, close the parentheses, all divided by 6. So we're going to graph our two equations. So hard to see if I zoom in. Alright, we're going to find when the two graphs intersect. So let's actually change our window from, let's do from -10 to +10, and then our y min will be -10 to +20. This will help us get a better view of what's going on here. So we're going to have to find the intersection of these points. So we can go to calc, intersect. This is our first curve. This is our second curve. Our guess for the intersection is going to be when looks like the graphs are intersecting. So we have an intersection at negative 3.726 and 1.095. So point A and B, we intersect at sorry, this is not a vector, at negative 3.726 and 1.096. So that's when we intersect. All right. Now we need to figure out how much the planes miss colliding. So for A, right, T is equal to negative 3.726 plus 4 over 2. So plugging in our x value. For B, T is going to be equal to negative 3.726 minus 4 divided by 3. All right. So we should plug this into our calculator. So plug this into your calculator, and you should get T is equal to 0.137 and 2.575. So these are, we're trying to find so this will find the different times that the planes pass the intersection of, I guess, well, not, how would you describe their distance paths of their flight paths. So the two planes are going to miss by subtract this value from that value. That should give us 2.438 seconds. So the idea is that with time we can figure out how much the planes miss colliding. So I think that's a pretty cool problem. All right, that's parametric equations. Have a great day.